Hi everyone, welcome to this STEM experiment. I'm Miss Libby, the Youth Services Librarian over at the Lodi Memorial Library. This time we are going to be doing 3 separate experiments, but they all have one thing in common. They're all about air. We're going to be talking about vortexes, air pressure, and using air to reduce friction. So we are going to start with air pressure, go on to friction, and end with vortexes. So let's get right to it. Okay, this air experiment demonstrates air pressure. We're going to be using fire for this experiment, so if you're going to do this one at home, you must have an adult with you at all times. So what we have here is an empty wide mouth jar, a balloon with water in it that's just too big to fit inside the jar, a piece of paper, and a match. So, as I said, the balloon won't fit in the jar. It won't go any further into the jar than this. So it's barely going past the mouth there. But we're going to use air pressure to change that. So the first thing I'm going to do is I'm going to light my piece of paper on fire, and this is where you have to be very careful and have an adult help you. So once your piece of paper is on fire, put it in the jar and put your balloon on top, and you can see right away the balloon is going down quite far into the jar. The reason for this is that fire needs oxygen, and it is eating up all the oxygen inside the jar. The balloon is acting like a seal, but not a perfect seal. It's letting some air out, but it's not letting any more air back in. So what's happening is there is low pressure inside the jar, where before the pressure outside the jar and inside the jar were the same. So since there's low pressure in the jar, the air from outside the jar is pressing on the balloon and making it go further into our jar. So that is how you put a balloon inside a jar. You can also do this experiment at home with hard-boiled eggs, but this is much less messy and doesn't waste any food. One more thing. Remember I said that the air was coming out the sides, but no air was coming back in? If I try to take this balloon out, I am putting quite a bit of pressure on that, and it is not coming out. So what I'm going to have to do is probably pop this balloon to get it out. That is how much the air pressure pushed the balloon into this jar. All right, so that's it for this air experiment. Okay, we're a little close to the table for this experiment because we are going to be making a hovercraft. To do that, we're going to be using a balloon, a CD, and a cap that I've attached to the CD with a glue gun. You could use a strong adhesive, but the glue gun works best. When you put your cap, make sure it's centered so that it goes over the hole in the bottom of the CD. You can use a lot of different kinds of caps for this. I used a cap from dish detergent. You can use a solid cap like this. All you need to do is place some holes in it, so for air to pass through, but for air to pass through slowly. You don't want a big hole. So you can have an adult take a push pin and make several small holes in your cap. What I've done is I've made a hole in my cap right over the hole that the liquid comes out. So we have our hovercraft all set. I just need to blow up this balloon so that we can get it moving. Now before we do this, I want to show you, if I tap this CD, it's going a little bit, but not really far. But let's see what we can do to change that. So the hardest part of this experiment is putting the balloon on the lid without all the air escaping. You can't tie it off, but what you can do is twist it to give you some more time. So what you're going to do is you're going to take the bottom, you're going to stretch it and place it over your cap. And, all right, so now I'm going to untwist it. And you can hear some of the air escaping. But, as you can see, it's moving around. And it's moving around somewhat by itself. But if I push it, it'll go quite far. So what's happening is the air is escaping underneath the CD. And it's creating a cushion of air, which lessens the friction between the CD and the table, which means I can push it a lot more easily. Some people think this kind of technology is the key to clean vehicles in the future, stop our dependence on gasoline, but we still haven't yet made it quite cheap enough or easy enough for the average person to have a hovercraft. But maybe in the future we will. So this craft is a lot of fun. It's a craft, it's a science experiment, and you can do it right at home. So next experiment. We are going to be using water for our last air experiment because it is easier for us to create and see a vortex. You might be familiar with a vortex of air, more commonly known as a tornado, which is a weather phenomenon which can be very destructive. But there are other vortexes that you may have noticed. Have you ever had a full bathtub, unplugged it, and you see the water swirling around the drain? That is a vortex. And we're going to be creating that with 2 empty bottles that have been glued and taped together. The one on the bottom is filled about 2/3 of the way with water. I've dyed it blue so it's easier to see on camera. Now, what I'm going to do is I'm going to flip this over and swirl the bottle to create a vortex. Ready? Okay, do you see that in the middle? That was our vortex. Now let me show you what happens if we don't create a vortex. If I just flip it over, see the glug, glug, glug. Is it going down slower or faster than it was before? It's going into the other bottle much slower, right? And that is because the air from one bottle and the water in the other bottle are having to take turns, which is why it took so long. Whereas if we make a vortex, the spinning of the water creates a place for both the air and the water to go down at the same time, making it faster. Okay, so that is our last air experiment for this week. I hope you had fun with these experiments, and I will see you next time for STEM experiments. Bye, everybody.